Hello class, this is a continuation on sketching polynomials. In this video we'll be looking at repeated roots. Since the roots of a factored polynomial can be easily identified, so for example, if we had this in factored form, we know it is a even degree polynomial with the x-intercepts at -2, +4, and it is concave up, so it starts here, ends on the same side. This is a cubic of odd degree, so we know it starts here, ends here, as well as we know the x-intercepts relate with the factors -4, +1, +3, -4, +1, +3, and we know that in between any two x-intercepts there is a turning point and a turning point. How then are polynomials with repeated roots going to be sketched? So for example, we could very well have a polynomial like this, which we could simplify to become x plus 3 all squared. So if we were to label our x-intercepts, they're the same point, -3, -3. Likewise with this, we could simplify these repeated roots as x plus 2 all squared times x minus 1. We can find the x-intercepts. There's 2 at -2 and 1 at 5. And, you get the idea. This one with 3 has 3 repeated ones. So, how would we go about sketching these? Well, consider that the roots of a polynomial are both the x-intercept and that there must be a turning point in between any two x-intercepts. So if we have two x-intercepts here, there has to be a turning point somewhere in between them. What happens if they're the same x-intercept? Well, I'll give you some moments to think about it. Well, to sketch these, repeated roots of even degree are actually both an x-intercept and a turning point. So this pretty much tells us that there's a turning point at -3, because we can now find the x-intercept here. It's at x equals -3, and because it's a repeated root of even degree, there's a x-intercept and a turning point at that point. And there we have it. Likewise with this is in total it's a cubic, so we'll start here, end here, and there should be something in between, so it should look something like this. However, because we have an x-intercept at -2 and it's a repeated root, so -2 is here, the other x-intercept is at +5, which is here. This repeated root should look something like, let's see if I can sketch this properly. Whoops. Should look something like this. Not 100% accurate, but I think you get the idea. And then it turns like that. So at -2, this repeated root at -2 tells us that there's a turning point at that point. So that's of even degree. Now with odd degree repeated roots, they're both an x-intercept and a horizontal point of inflection. We'll learn much more about this later on, but in general what this would look like is a cubic. The most basic cubic looks something like this. And notice how there's sort of a point here in the middle where it stops and then it increases again. That's what this will look like here. I'll demonstrate. Let's find the x-intercepts first. It's going to be at 2 and -4. And let's take a look at the general shape of this. It's going to be degree 3 plus degree 1. So this is a quartic. So it's going to start here, end here. The first intercept is at 4. So it's going to do something like come on. Let's try again. Something like this. Let's try and sketch this a little bit neater. Should be something like this to begin with. But now take a look. It's a cubic. It should end here. Normally you might think it'll just go straight through, like so. However, a horizontal point of inflection will look something like this. It'll come to a stop, or it'll appear to come to a stop like this. Let me try and make that a little bit better. And then goes back up, like so. So that's going to be at -4, this point here. And this triple repeated root is going to be at +2. So this is what this graph would look like. And let's do this one last one. It is degree 3 plus degree 2. That would make it degree 5. So it's an odd degree. It'll start here, end here, because we know it's a positive coefficient. X-intercepts at -3 and +1. And so this is a horizontal point of inflection. So it's going to do, actually it's going to do something like, you know what, I'm not going to use the technology anymore. It should be something like this. It flatlines a little bit, but then it continues to rise like this. But then this is also a repeated root, so it should do something like this, which means there's a turning point in between these two. So it should look something like that altogether. And that there is the graph of this cubic. Oh, sorry, quintic. It's degree 5. So that's the general idea of sketching repeated roots. We have some examples here, and I'll see you in the next video for that. Okay, so see you then.